Let's continue solving for the orbits of a certain permutation sigma. This time, our sigma is a permutation on S8, okay, because we have 8 elements here. So what we need to do here is to look for the orbits, our set containing related elements. And this is very important as we move further to cycles and other concepts pertaining on permutation and other topics. So we will talk about orbits. The first and foremost idea is that, of course, to be guided, our orbits should be disjoint. So the idea of not sharing any elements to other sets of specific orbits, that should be put into mind. At the same time, if we're going to combine all orbits, it would be the S8 itself. So we'll have this idea that for A and B, element of A, or this case S8, let A be related to B if and only if B is a result if we're going to operate our sigma n times and picking on a certain element or mapping for a certain by the way, that's A in general. A. Okay? So for some n element of Z, we stop as soon as we could see just a repeated pattern. So let's do it like this. Of course, we will start with the mapping of 1, just 1 itself. Okay, 1 is mapped to 5, as you can see here, just like that. That would mean that 1 is related to 5. Okay, and 5 is related to 1 because 5 results from a certain mapping from 1. Okay, but we do not end there because we could also continue or use the second mapping of 1. But as you can see, this is actually just similar to the mapping of 5, because if you have here sigma squared and you have your sigma 1, 2, 3, 4, 5, 6, 7, 8, that's 5, 6, 2, 4, 8, 3, 1, 7, and all multiplied to itself. 1, 2, 3, 4, 5, 6, 7, 8. You have 5, 6, 2, 4, 8, 3, 1, 7, following the correct multiplication of permutations. If you're going to have here, that's square here, this is what it meant. 1 is mapped to 5. When you go here, you will just be focusing on 5 now, which is mapped to 8. So the second mapping of 1, or sigma squared in this, just for the expression, reading of the expression, is similar to the mapping of 5 because 5 is already the result when we look at the first mapping of 1. This is again resulting to 8 because 5 here ends with 8. If we are going to have cube here of 1, this is still sigma of 8 because you already have the cube of 1 now. And your 8 here, without even looking at this, proceeding immediately to the origin of the given permutation here, it's mapped to 7. Then if we're going to continue further, this is actually sigma of 7, we go back to 1. And we just ended a certain repetition, because if we're going to continue 1, we'll just return to 5, then 8, 7, and 1. Therefore, the first orbit, it's a set containing the elements 1, 5, 8, and 7. We can rearrange the elements here because this is a set. But if we are going to move further, I'm not declaring it right now, but if it's possible to reach the ideas of cycles, it's very important to really follow a certain order. So it will be 1, 5, 8, and 7. But of course, as mentioned, you can rearrange here because we're still in orbits and we have sets. So once we are done with 1, we're already done with 5, 8, and 7. Let's jump to 2. Okay, 2 is mapped to 6. So if we're going to have this notation, so it's just simply mapping of 6. 6 is mapped to 3. Then you have here cube of 2, that's sigma of 3. 3 will return to 2. This time, our set would be the orbit of 2 6, and 3, or again 2, 3, 6 if you would like to arrange it, rearrange it, and it's possible again as mentioned because we are still under the idea of orbits. We are done with 2, 3, 4, so let's proceed to 4. Okay, but 4 is just mapped to 4, so we have only this set for the orbit of 4. So we have this, okay, 1, 2, and 3 orbits. And as you can see, these orbits are disjoint because they do not share any elements. And if we're going to combine them into one, you have here 1, 5, 8, 7. This would be your 2, 3, and 6 in your 4 here. If we're going to combine all the sets, you will return to the original set of S8, or yeah, S8. So that's the idea as well. So this is for this item. Thank you very much for watching.